All right, we're going to get started, and I am going to give people a few more minutes to roll in, and in so doing, give you a little preview. This, in case you haven't noticed, because it's a little early in the morning. Well, it's not that early, but it's early if you're from the West Coast, which I am. This whole room for today is essentially educational kinds of things using Jupyter. So I preview a few things in this talk. I didn't even realize I was doing this, but we're hearing from folks in Canada who have set up a very interesting system for dealing with Jupyter hubs in the immediately preceding session after this one. So I recommend that if you like this session, you'll probably like the next one even better, which means if you don't like this session, you should stay for the next one because it might be what you really wanted. And then there's a lunch break, which I'm sure everyone likes. That doesn't happen in this room. And there's a bunch of additional educational stuff. So I just wanted to flag that in case this is your flavor. You might want to track this room pretty closely. Okay, so I'll introduce myself really quickly. I am Laura Noren. I was recently at NYU's Center for Data Science, where I was a postdoc, and I just recently moved to California to take a job at a cybersecurity startup where I'm still doing research on data science ethics, which is what I was doing before. And along the ethical piece, I started looking at career paths for people. So I'm sort of foreshadowing something that's going to come up in this talk about sustainable career paths for postdocs. But I didn't necessarily intend to be the poster child for that, but now I kind of am. And then my co-author is Anthony Swen, who was also a postdoc while we were writing this, but has since gotten a permanent position at Berkeley, but he couldn't join us today. So shout out to Anthony, but he's not here. Always good to thank our sponsors. So the Morse Sloan Data Science Environment, that's how Anthony and I met, and they funded a grant that went to NYU, UC Berkeley, and UW Seattle to study how data science was intersecting with higher education. And I also have to thank the team Jupyter, because lots and lots of the stuff that I'm going to talk about is something that they've developed, problems that they've flagged and then decided to solve, which is super awesome. We should all be thankful. Okay, so the challenge that we are looking for is how can we teach all the students who want to learn computer science, statistics, data science, that in a way that's pedagogically compelling, that's a good runway for the work that these students are going to do in their future, that's reproducible, that's scalable to large classes and small classes, that's affordable. Cloud credits are either free if you're lucky or very expensive if you're not, and that doesn't burn out the instructors, which if you've done this before, you maybe understand where I'm coming from on that one. So the team, so I'm sure everyone in this room is familiar with Jupyter notebooks, and one of the pain points with Jupyter notebooks when you're trying to use them in a classroom environment is just getting them set up in the first place. Everyone's using a different operating system, different computers. If you go student by student, it can be relatively painful to get them all in exactly the same place at exactly the same moment, and it's a lot of instructor time. So if you use a Jupyter hub, you can kind of end up providing a more unified environment, which is nice for sort of pushing out assignments, doing grading work, shutting down notebook contributions when you want to start grading, and those kinds of things. So the way this works is, I'm not going to get too deep into infrastructural details because we're mostly working on the political infrastructure in this talk. But you start with to get a multi-user hub, you have a configurable HTTP proxy, and then you set up a whole bunch of single-user Jupyter notebook instances on that proxy so that you can get a unified environment. So that's essentially what you end up with. The hub launches this proxy, and the proxy forwards all requests to the hub so that you can have deal with user authentication, like I said, push out assignments, grade assignments, shut things down, kind of monitor what's happening a little bit. But it's a little challenging to set this up at scale. So there is documentation to set up 0 to Jupyter Hub if you really want to try this and you haven't done it before. That documentation exists. It's still fairly, if you're really new to this, it will still be a little challenging to use that documentation to do it. So good luck. The long version is, if you can get this set up, it's really, really good for teaching because it gives you that unified environment, but it has taken quite a bit of postdoc and faculty labor to get it to work. So we're trying to figure out how we can help that kind of environment scale across universities that may not have the, I don't know, volunteer spirit that some schools do, or the funding. Funding would be nice. It's in short supply. So just to give you a little background on why we need this, the demand for computer science, data science, statistics teaching is huge and growing. The students really, really want this. They've all been told that they're supposed to study STEM and it's going to get them good jobs. We're certainly trying to encourage more women to go into these fields, and to some degree it's working. But we can't really hire faculty fast enough to keep up with this demand, so the class sizes are getting pretty large. And so that's part of the problem. And the other part of the problem is not only can we struggle to hire faculty because they're being, I don't know, hired by cybersecurity startups in California. So someone else is hiring them. We also just see that universities don't have, their funding for computer science lines is not expanding as fast as the demand for these classes. So we're kind of at a crunch point. So if you use a Jupyter Hub, you can scale to hit a class of that size, which is a pretty large class. Just to take an example, UC Berkeley, when they introduced their Data 8 class, that class now has over 1,000 students who are trying to enroll for that. So I mean, we call them supersized classes at NYU, and they hit 300. So 1,000 is like a super sized class, and it's difficult to manage. So you really don't have the faculty time to go student by student and make sure that they've got the infrastructure set up and they have all the updates. And if they get a new laptop, they're not somehow drowning halfway through the semester because they can't really remember how to install everything. So what I'm going to present is a bunch of case studies that were based on qualitative interviews with schools kind of across the range of like funding support, class size, private liberal arts schools, big public schools, to try to come up with, like what's happening out there and how can the Jupyter team, and maybe some other folks like Amazon Web Services or Google Cloud, start to support this kind of educational initiative. So we'll just jump right into Berkeley. I think everyone's familiar with the idea that Jupyter is kind of born at Berkeley, and Berkeley does continue to do a lot of the infrastructure development for the software, although it has now expanded greatly, which is why so many people are in this room and at this conference. So their infrastructure and support team, they have 2 tenured professors who are hands-on doing development work and also managing the team of 1 full-time staff member who is here at this conference, 10 postdocs, and a bunch of grad students who are very competent and very dedicated. And there's a nice kind of momentum and inertia at that school supporting this kind of thing. There's a big team working on it, and it's a known entity, and people to some degree get a little bit rewarded for working on this in terms of maybe having some opportunity to become that 1 full-time staff person or get a half line on a grant or something like that. Their classes are huge. So they have 1,000 students in the actual class, and then they also support an edX class, which is even bigger by an order of magnitude. So they work pretty closely with their IT staff, which is kind of unique, to handle the installations for a large class that's like 1,000 students, or for the edX class that's 10,000. So that's huge, and they're unique in that way. But it means that they run into the problems of scale really quickly, which is good for the rest of us who are trying to use these techniques. And they pay for it partly, if you're Berkeley and you're close to the West Coast and you're really high profile, you can get donations of cloud credits. So that is also unique for them. So it's great that they're seeing these problems and trying to build out infrastructure for everyone else who's going to reach that kind of scale, or even half or a third of that scale. But they have some benefits that not all schools have. Like, they can attract the attention of Google Cloud and say, hey, we need some more cloud credits. Could you give us, the school directly, a bunch of cloud credits? Because what I think a lot of professors are running into is their students might be able to individually get some free cloud credits, but it's really hard to use those to set up a hub because you can't aggregate them. And you're not expecting like your freshman or something like that to please set up a Jupyter Hub. I know you don't know how to do much of anything, but if you could please set up a Jupyter Hub, that'd be awesome. So the challenge is there, but they are facing challenges, right? This is not like an ideal situation. The graduate students and postdocs who are working on this program, that's a fairly precarious way to run this kind of situation, unless the grants are dedicated to supporting Jupyter, which they're generally not. that may not last forever. And these folks are not necessarily getting rewarded for doing this kind of work. This does not necessarily get them a tenure track position. And if that's what it takes to continue to do this kind of work, then this is not ideal. And the Bay Area is super expensive, and a lot of them are facing some pretty significant financial problems because they can't really afford housing in the Bay Area. And Berkeley just recently decided that postdocs are not students and booted them out of student housing. So, ouch. We were never considered students, so we never had student housing, but at Berkeley they did. And then there are also just infrastructure problems. If you're relying on free crowd credits, that's also kind of precarious. When is Google or Amazon or Microsoft going to decide that they want to turn off the spigot on those? And then if you've based your entire infrastructure on getting those free cloud credits, you probably don't have it in your budget to suddenly start paying for them. And even if maybe they never turn off the spigot for a UC Berkeley, what about schools that can't get that or get it once and can't get it again? It just doesn't scale. And even if Berkeley, say, maybe has some extra cloud credits, it is very difficult to share them. Open source is great, but when it meets up with for-profit logic, it tends to be a difficult translation. So the next case is a much more typical case. I've talked to several people who work at small liberal arts universities, and their class sizes are much smaller, and so it's usually a professor says, hey, I'd like to set up a Jupyter hub. This is the latest and greatest now. Let me get going on this. My classes are much smaller. It's only like 20 or 30 students. How do they handle installations? It's usually a struggle. They don't tend to have quite such a close relationship with IT staff, in part because IT staff are pretty stretched. So they don't have the bandwidth to always dedicate time to a specific class. And they also don't necessarily, as most of us don't have specific money in educational budgets to support paying for a bunch of cloud credits. So money is an issue and time is an issue. And again, when the cloud providers just give the credits to students, that doesn't really work for this Jupyter hub setup. So from a career perspective, this all mostly falls on professors who don't even have postdocs to rely on or grad students of any kind, so it kind of puts them in a crunch. And again, like, this type of thing isn't super, like, usually you can't bring to your tenure committee, hey, I set up a Jupyter hub, please give me tenure. That's not a thing. So there's a lack of incentive there, at least at the formal recognition level. And there are some sustainability issues. If you have to continue to do this kind of thing over and over again, the burnout factor is pretty high. What if you were the ideal situation? Let's say you're at a big, wealthy private university, you have money, you have more IT staff. What does that look like? So I won't say who we talked to, but we talked to someone who is in exactly that situation. I talked to someone on the IT staff, and they said, yeah, I had time, not tons of time, but I had time set up specifically to deal with setting up a Jupyter hub. I had a budget that I could spend, so we were able to hire a firm to go onto AWS and just set up our Jupyter hub. So I didn't really have to completely deal with that. He wasn't thrilled with the way that they set it up, though. So he ended up going in. So the university, in this case, covers all the costs from the general funds. Nice. Rare, but nice. And they didn't love the way that the person had set up, the outside contractor set it up, because it was too expensive. So they made some switches in the way that they run the instances to make it a little bit cheaper. And if you happen to want links to figure out what is the best strategy for you, that particular person has a GitHub repo with all the installation code and a little mathematical formula, so you can put in how many instances do you have and how much would it cost if you set it up in one way versus another way, and then also all the instructions to set it up in his alternative way, which is using EC2 instances. So if you're interested in that, that's up there. It still is a little bit pricey because they did not have donated cloud credits because they didn't have to worry about that. They just paid for them. It's an option. So if you don't have them and you want to know how much it costs, that GitHub repo is actually pretty useful. So just to give you a sense too, The max cost could be something like $717 a month for 20 users that can be brought down to 34, which is much more manageable, but that's the kind of cost structure you're looking at on a monthly basis for like a typical 20-ish student class. So their problem is that their model might be functional for them, and it is, and they're going to scale that out to a bunch of other classes, and again, dedicate their IT staff time and hire on consultants as needed. But that just doesn't work for most schools where they don't have that kind of budget. So the ideal scenario, we can learn a few things from it because they did, beautifully contribute to the knowledge on how much this costs. But they also haven't quite figured out if that particular setup is going to work as their classes get larger. But again, it's a big private wealthy university, so their classes are going to be pretty small. They're probably not going to have a 1,000 person class. So that's just outside of their model. So the final model, well, sort of, yeah, is this Canadian model. I don't know if we have the Canadians in the house. Hi. So we like this model a lot, and I'm sure you guys will probably explain in greater detail than I will, but their model is that they have a network that is sort of Canada-wide, and it supports about 10-ish universities. This may have changed since we spoke. And they have one full-time person who does sysadmin work, which is great. I feel like that person was stretched a little bit thin, but at least it is functioning. And then they also have kind of a time donation from professors at 10 different institutions. So it's not like that one person completely negates the need for other people to help. Their classes can be up to 200 to 300 students, but they're not necessarily bigger than that, and they may have some scale issues if they start to get Berkeley-sized classes or even 500 students at once hitting these servers. So they're able to work with Compute Canada, which is a national infrastructure that the United States doesn't quite have. And they did, just like all these other schools, they bootstrapped a lot of this off staff time and enthusiasm for the project. So they are able to get grants. I mean, it's easier when you have a national network set up to get grants from national and province level actors. And they also, they do still run on a lot of goodwill and volunteer time. So I'm not trying to suggest that Canada is somehow paying everyone for every minute, and the United States is expecting all volunteer time. It's not quite that simple, but they do have some paid staff who kind of keep the coordination going. So they still are relying on quite a bit of donated time, but they're a little bit more rewarded for this work than maybe some of the folks in the United States, especially the postdocs who are not sure where they're going to work next. They may have some scalability issues, but it is this might be a more replicable model than, say, the super wealthy university. So, yeah, they have a funding hurdle, not a wall. They are also able to scale out to high school because it's a national model, not a university-based situation, which is pretty exciting for those of us who are trying to build that pipeline back a little farther than freshman year. And their teachers are having a little more time to focus on course development and get those course modules shared in a network. So what do we recommend? One thing that has come up after we really took a hard look at that liberal arts case, where you're having classes that are like 20 to 30 students, could there be another way to do this that's not quite so complicated as supporting a 1,000 person class? Yes. So there is now a new package that UV has put together called the littlest Jupyter Hub. So if you're in the situation where you just have a small class and you don't really want to have to deal with setting up Kubernetes, there is a new set of instructions, set of docs out there to support that kind of thing. And this is definitely something we recommend for the smaller classes because you won't have to wait for some of this more complicated work that goes into setting up a national or regional hub system. So this works for lots of cases where you have less than 50 students. I wouldn't necessarily recommend it for more than that. It doesn't scale bigger than that. If you happen to have a very motivated either professor who has a lot of infrastructure available or IT staff, you can run this without having to deal with the cloud credits if you're willing to set it up on your own server. which is, it's complicated, but the docs are out there to lead you through that. So if you don't want to deal with the Amazons, Googles, and Microsofts of the world or pay for that stuff, this is one way to get around that. But it does take a lot of money. It takes a lot of time and expertise. But the next version is, what if you're not that? What if you want to do scale and you can't do it, or you really don't want to have to try to set up your own server? You can. We're promoting the idea. We're trying to find support for setting up a federated model a little more like Canada, but not necessarily synonymous with Canada's model, because the United States has many more schools than Canada does. So a regional, like their network supports maybe 10-ish, 15-ish schools. We have many more than that. So it doesn't really work to be completely synonymous. But we think that if you set up this network, it alleviates a lot of the pain points with setting up the infrastructure, and it partially centralizes the collection of cloud credits. So if we did want to, say, approach someone like an Amazon Web Services or a Google Cloud, those kinds of entities would be much more interested in having a conversation where they're only distributing credits to a small number of players rather than one school after the next, each at a time. That doesn't really scale for them because it's too many relationships to manage. But if there were kind of a collection and distribution system that was not run by them, but run by some third party, that would be more feasible. So that's one of the reasons we like this. And it also can help, besides getting the infrastructure set up, once there are teaching modules ready to go from different schools, those things can be shared through this network too. And we're not the only ones thinking about that. The Journal of Open Source Education is already kind of doing some of that. So if you want to be using Jupyter notebooks in your classes and you want to know what's out there, there is already a journal out there, and we have people in this room who are working on that. So there's a link in the slides that I uploaded to all of these things, including that journal. So, and if you want to if you are really into teaching and you want to get credit for the stuff you've done, you can publish it to the Journal of Open Source Education, and then that's a citation you can get. So it's set up to work with those incentives that are big academic incentives. So what would this look like? So there already is, the National Science Foundation has set up the big data innovation hubs and spokes, and some of those hubs and spokes are already trying to work on this. So theoretically, this system already covers every school in the United States. So there's already a network out there. It's easier for the cloud companies to donate into that network, probably, than to just go school by school. But there are some cons. So the staff support in the big data hubs is pretty limited right now. It's really tough for, there's, I don't know, maybe about a total of 10 full-time people for the entire country. And they have to do many other things besides just run Jupyter hubs. So at the moment, that network exists, but doesn't have the staff capacity to layer on this additional challenge. But we could, at least we should probably take advantage of the communications infrastructure we already have. So that's one ongoing idea. The other idea is people have suggested, well, hey, we already have state university systems. The University of California is a system. We could, federate that a little bit. The problem with that is that there's still 50 of them. Pros would be states might be able to better collect state-based grants, possibly some private foundation grants or local high net worth people who are really interested in education, of which there are actually quite a few, might be more interested in donating directly to the state than to some larger federal-ish entity. But if you go this route, it does kind of leave out weaker states that are never going to do this. We can all think of some. I'm not going to say what those states might be, or private colleges. Like, how do they get in this network if this is run by the state? The NSF Big Data Hubs and Spokes are much more agnostic about who's doing what. So those are the two ideas that we're really pursuing right now. This is still kind of a work in progress. We haven't quite figured it out. Just to remind you, why would we do this at all? There is a national imperative to just increase the scope and the quality and the rigor of STEM education at scale. So we're really trying to help figure out what that looks like and keep it high quality, keep what students are learning right exactly in line with what they're going to be using as they continue to do research in graduate school, or if they leave academia, what they're doing in their jobs. if you get this kind of steady IT support and cloud credits, you can scale it to small institutions, which we're particularly interested in. They tend to be the ones that get forgotten or kind of react later. And right now, those schools a lot of times just end up calling Berkeley and trying to get IT support from Berkeley, and that just doesn't work. It's very beautiful to watch how much time the postdocs and the grad students try to put in to help those folks who are really passionate about getting this set up, but it just doesn't work. And we really need to continue thinking about the larger problem of postdoc and grad student labor, especially, like, it's obvious that everyone here cares deeply about education, but if education isn't what's going to get these folks a job, they kind of fall out the end of a pipeline where they've been supporting this infrastructure, building this stuff, and then they don't have jobs to go to where they can continue to work on that. Like, don't feel bad for me, I have a great job, but it's unlikely that I'm going to be able to really continue working on much educational support. I can do lots of research, but education is really something that happens within universities. And if we lose those postdocs, we lose all of the work that, not all of the work they've done, the work remains, but you lose all their embodied knowledge and all their passion to industry. I think we're trying to prevent some of that. So I promised that I would leave time for questions, and also you probably are sick of hearing anyone speak after 30 minutes, or at least sick of hearing me. So I'm happy to take questions, or even hear from other people in the audience. I see familiar faces who have been working on some of these challenges as well. So yeah, what questions do you have? Thoughts about this? Do you think it's realistic? Oh, sure. How many of you are getting cloud credits donated from one of the big three? So, like 4-ish. How many of you haven't really set this up yet? So that's an irrelevant question. Okay, slightly more. So all of you who didn't raise your hands are doing this in some other way, which is super creative, and I'm curious what that looks like. Yeah. Yes. Yeah, how are you doing it?
So there's a couple of ways. I do it for small classes, which would be 30, 40 students and stuff like that. Through NSF, there's JetStream and Atmosphere, which are free cloud services. So it's very easy to take a document that has my help on it and then just spin it up as I need it on those. So in that case, it's free. But again, depending on the teacher and how familiar they are, it's not very hard to do that, but it may still be beyond people who just don't know how to do that.
Or who just don't know.
Yeah.
How many people are doing that type of thing? So you are unique. Yeah, so that's a pro tip. Try that. Does anyone else have a workaround for this? I don't know, workaround might be, yeah.
It's similar, but I also have a NSF partnership with the National Data Service out of NCSA, and they provide hosting on the same games.
How big are your classes?
They're generally workshops for science information partners, so it can range from 20 to 60 people at a time.
Cool. Do you see any problems as you scale up to 60, or it still works pretty well?
It has crapped out before, but one of the nice parts about the partnership with NDS is that they have someone actively monitoring. So if there are issues, they'll try and find the workaround.
That's cool. Does anyone else have workarounds they want to share in the back? Yeah. They haven't come up in any of the interviews, although we were interviewing people who specifically were having trouble with Jupyter Hub, so that might have come up, but it's a bit of a sampling bias that we were already talking to people who were trying to use Jupyter Hubs. Does anyone else use that?
Microsoft Azure notebooks in the first 3 weeks of my course last fall because of delays of getting our Jupyter Hub set up. And as an add-on story to that, at GW, we do have one Jupyter Hub set up that's on Amazon, AWS, and they're paying for the cloud. It was set up through Academic Technologies, which is a branch under libraries in my universities. And it took me about 9 months and hundreds of emails to actually finally convince them to set this up for us for the class. And now they've made the commitment to continue supporting it for the next year. But I have no sense of the sustainability. They could pull the rug under my feet at any point in time. So it's yeah. And I started with the Microsoft Azure notebooks. I didn't quite like it. They don't. It's a bit clunky. You didn't get a terminal working. There's several things that I couldn't quite do like I wanted. But it was a drag because once the students started using notebooks, then the Jupyter Hub came online, and to change them from one platform to another was hugely difficult. Once they get used to using one thing, they want to continue.
Yeah, it was an experiment in some costs. Yeah.
So I'm at a small liberal arts college, which is good to start out to try. So we set up one machine. It was an old computer we had in the lab, and then I got a couple of classes going. And then physics was interested, so just to be safe, we set up another one. And then chemistry was interested, and so at that point, rather than having a bunch of these little machines, we got IT to finally invest some money and time. And so that all has been moved. It took 4 years to do that, but we had the evidence that it was really being used, and there was enough interest. But the one other thing I would say is that Jupyter actually covers many different languages, and not every language has the same server requirements.
How big were the classes that you're supporting in all three of those, or roughly?
Probably on average about 20 people per course, and probably about 4 courses per semester.
And how long, once you had gone to IT with the evidence that this was a demand, how long did it take to get all of that switched over from your local home?
Basically, I had to sit down with an IT person, and we just went through every single step. This was before UV's very nice guide where you can just run. So they basically had to reinvent that.
And on the political side, how long did it take to get to that week, the beautiful week? Well, I don't know if it was beautiful. It was a difficult week.
Overall, 4 years through different. It wasn't a constant push, but it was a trickling of requests, and then in the end, it took a lot of meetings and who was going to own it. It started out on there was a time where it was on the cluster as well, and now it's on its own computer. But again, like Lorena said, this could go away. We don't really own it. It's the IT that owns it, and we're sort of at their whim.
Yeah.
So it seems to me like it's very common for us in education to want this kind of resource, this kind of infrastructure, and we often end up trying to convince someone that been higher up in the school or something to support it. So we don't have to be teachers at the same time that we are learning something completely new about how to set up a Jupyter Hub or something. So I'm thinking, could we perhaps manage to pool some marketing resource for teachers realizing the potential of having this infrastructure on how to convince or like, hello school leader, look at this marketing stuff. This will make you realize the benefit for us teachers if we have this kind of resource. Could you help us set this up? This is the reasons of helping us do that. And so the kind of situation you were in, if you have 4 years to try to convey things, and they may ask, oh, please prove that it's useful. And then you need to end up doing it yourself, because it was my situation. I wanted to convince my school to please do this, but I ended up doing
Right. In order to prove it, you have to do it yourself, in which case you've kind of negated what you were asking for in the first place.
So I just have a bit of advice about how to navigate within the university. So the IT office is meant to serve the entire university. Most universities also have some sort of an instructional design or a center for teaching and learning. And so if you wish to have a hub, and let's say you're a chemist, and if you can find someone in digital humanities that also wants a hub, and maybe somebody else in engineering, you might be able to bring representatives from the Faculty of Science, the Faculty of Arts, the Faculty of Engineering together to go talk to the Vice Provost Academic or the Chief Information Officer and say, we have a multidisciplinary interest in this new technology. It's not just for computer science, it's not just for statistics. And I think that's the kind of thing that topples those offices into becoming advocates for you rather than opponents.
So if you were to go that route, could you bring evidence from this school and that school and other schools that have used it across disciplines, or do you really have to build it within your own university and then demonstrate that it's in fact useful across your specific departments?
I mean, I can answer a personal question, but the testimony is persuasive, right? And so the testimony from Fernando's talk earlier today shows this incredible interdisciplinary momentum, and I think it can help drive the interest. But some of those folks in IT are busy, they got their own thing, and they're like, why would I build this thing for you? Who would use it here? So they also want to see that there's someone that's actually going to use it. Anyway, there's a lot of momentum here.
Right, so like a dean or someone can understand if X, Y, and Z schools are seeing that this is useful across chemistry, physics, digital humanities, and statistics, then probably we should think about that. But is that persuasive to someone in IT? Do you always have to go all the way up to come down again? Or
Someone has to pay for it. You have to go to the person who holds the budget.
in which case you do have to go to the dean level.
Dean of library, whatever,
Something, yeah.
We're not using Jupyter Cloud, but we've got a number of servers. We're actually in engineering, and all students have accounts on servers. And so I got Anaconda installed on all the servers with Jupyter. And so the students can do, if they don't want to have Jupyter installed on their machines, they can tunnel into the server, and they can run Jupyter Notebook with an option that says no browser. And then, they're tunneled in, they can open a browser on their local machine and go to a local host port, which will then open a connection on the server, and so they can use Jupyter Notebook as though it's on their local machine. And it's fairly easy to convince IT people to install Anaconda on the server. It's not a big deal to get Anaconda installed. And that is the way we're kind of working in Jupyter Notebook.
That's interesting.
Michigan State has done a very similar thing. We have a group of servers that we host in the College of Engineering, but we do actually use a Jupyter Hub, and so students can request an account, and that will give them access to their own hub instance on our server. So we host everything in-house, and that's a relatively simple process because most, and this is of course coming from a university of our size, but we had the infrastructure currently in place, and so convincing individuals that we should have access to some of the idle space for our own use was less of a challenge. So I guess maybe the takeaway could be, maybe don't consider new resources need to be allocated, but somewhere in the university, somewhere, there should be or probably is some kind of idle resource that's not being fully taken advantage of.
It strikes me that it is typically, some disciplines are more able to be aware of what might be idle than others, and trying to navigate your own bureaucracy to figure out like should I go through libraries? Should I go through my own school? Like that in itself is a complicated question for lots of people. We probably have time for maybe one more comment or question. Does anyone want to volunteer something else that's working? Yes. I think we had a similar comment about that. So that's That's awesome. And I think we have actually come to the end of the time, and I want to make sure I give everyone enough of a break, because I know you were all just fed coffee, so it's an input-output situation. So thank you all for coming. Feel free to get in touch if you have questions. The Jupyter team will continue to help as much as possible, and we will continue to push for some kind of model beyond littlest Jupyter hubs that works for the, at scale a little bit better and can maybe distribute some cloud credits. So if you happen to be lurking in the audience and you have the capacity to release some of those cloud credits to a federated model, come talk to me. I'm looking for you guys, the Google Clouds and Azures of the world. So thanks for coming.